Hi friends, let me see about HEYSLER chart and lumped heat analysis. So before going to that, I would like to show the graph from the heat and mass transfer data book, which will be most useful for solving the problems in graphical way. So here we know that T minus T1, T infinity minus Ti, which is equal to 1 minus T by infinitive, T1 minus T infinitive. So based on this value, the y-axis value will be found for the value of T minus T1 divided by T1 minus T infinity. And this Bayart number or whatever the number they give in the numericals, h at root alpha t by k in this graph, and there are several HEYSLER chart graphs are there, and with that we are going to see in my presentation also. So for finite and semi-finite, so the Bayart number and all the things are there. HL by K, which is Bayart number. So in the x-axis, in the graph given here. So in the y-axis, the value here, this value T minus alpha minus T infinity, that can be found. Let me go to my presentation. So before going to the presentation, let me see lumped parameter analysis in three-dimensional unsteady condition equation. So in this, dou square T by dou square plus dou square T by dou square dou T by dou z square plus q triple dash divided by k, which is equal to 1 by alpha dou T by dou T, which is the equation number 1, which we seen already in the conduction. So alpha, which is equal to k by rho Cp, which is nothing but diffusivity for no heat generation and considering special variation of temperature only in x direction, dou square T by dou x only one x direction. We consider dou square T by dou x square 1 by alpha dou T by dou small t. For the solution to equation 2, we need two boundary conditions in x direction and one initial condition. So transient conduction, temperature change with time. So let me consider this is the space where we are giving heat inside. This is surface temperature, this is solid, where it has density, volume, specific heat, thermal conductivity, inside a distance, the small volume, temperature distribution, larger volume, temperature distribution in D varying, and lumped thermal cap analysis. Lumped analysis means sudden change in temperature variation. In this type of analysis, we neglect the temperature distribution inside the solid and only deal with the heat transfer between the solid and ambient fluid. So temperature in the solid is constant and is equal to the surface temperature. That is why it is neglected. And applying the energy equation, energy in minus energy out plus energy generated, which is equal to change in energy with respect to temperature. Generated and inside giving temperature both are equal because there is no change here, both in the case, both are neglected. So the heat out of the object boundary time, so which is equal to decrease in internal thermal energy of the object during the time. So HA Tt minus T infinity dt equal to mCp dt. HA Tt minus T infinity dt, which is equal to rho Cp dt, which is m equal to rho A. So HA rho Cp dt, which is equal to dt by dt minus T infinity. So we know that cross multiplying, simplifying the equation, will get dt by dt minus T infinity, HAS rho Cp dt, which is equal to theta equal to dt minus T infinity, dt d theta equal to dt, and reciprocal of z is called as the time constant. So the z we have to find d theta by dt minus HAS rho Cp view theta, this is volume V, d theta by theta, which is equal to HAS rho Cp V, d theta by theta, which is equal to z dt2, z equal to HAS rho Cp V, which is equal to integrating equation 2, we get theta equal to minus z plus c. So ln in the right side, which will go into the e power value, e power of minus zt plus c mathematically, theta which is equal to e power minus zt, c into this is a constant. So using the initial condition t equal to 0, dt equal to ti, and initial condition for the equation for 4, which is becoming, simplifying the equation, theta equal to theta I e power minus zt, and theta by theta I t equal to t theta minus t infinitive, ti minus t infinitive, which is e power this value. So here V by A is equal to characteristic length, V is equal to volume, A is equal to volume area. Let me see the same derived equation in the HMT data book in the equation of transient condition. So here lumped parameter. So this is the equation we have seen, t minus t infinity divided by t naught minus t infinity, which is in the page number of 57 in the heat and mass transfer data book. Each and every equation whatever we derived, which is available here with the notations. So we can go through this. So we can expect a big question in numerical part and 2 mark in HEYSLER chart, another thing we can expect. So coming to the HEYSLER chart part, we can see the Bayart number when it is given. Left side is theta value they will give, or they will give any 4 value. We have to find out this. The Frodde number they will give directly, or they will give alpha t by LC. If we find any 2 value, either Bayart number and theta or Bayart number and Frodde number, we can find out the third data here in this HEYSLER chart. So in this also, this is also from the HM data book only. So theta into Bayart number, here theta is this Bayart number. We can find out the Frodde number, that's what they given here. So thank you very much for listening the lecture. Thank you.